In this example, I want to demonstrate how to use frame analysis. So first we'll use the frame generator, and then we'll learn to use frame analysis. When we have long skinny parts like this, it makes more sense to use beam elements rather than use mesh elements. And so we're going to use two different frame sizes. So for these four vertical beams, I'm going to use a 6x6 square 1/2 inch wall thickness. And for the cross members, I'm going to use 3x3 square by 5/16 wall thickness. We'll put 500 pounds of force per inch, these four beam members at the top. And then to calculate the safety factor, we would take the yield strength of the material divided by the maximum stress, and the units will drop out, and that will give us our safety factor. We will also determine the reaction force at each of the four pin constraints on the legs. So let's look at how to set this up. First thing you should do is make sure that you have a project set up for saving all of the part files. If you're using Vault, you will first need to log into Vault so that you'll have access to the Content Center. Otherwise, if you're using Desktop Contact, you'll have direct access to the profiles for Frame. Now, we need to create a skeleton first, and here we can see that I've created some 2D sketches for a skeleton, and let's look a little bit at how I did that. So the first thing I did is I lofted two squares to create a surface body that I can then use for sketching 2D sketches on this face, and this face of the surface. Now notice I've offset this so that this face is vertical, the other faces are inclined, and if I edit that sketch, we can put in whatever distance we need if I want to get this back up to this location in the center, or however I want to put that offset. I'll turn on the visibility of the individual 2D sketches then I use for the cross members, and I'll turn off the visibility of the lofted surface. I'll then open up an assembly that I have placed the skeleton into, and so here we see our skeleton file placed into an assembly. And then I'll go to the Design tab, and I'll select Insert Frame Member, put it on ANSI Standard, and then I'll find ANSI Square, and I want Square Tube. So there's Rectangular Tube, here is Square Tube. It gives us a preview of the profile shape. For the size, I'm going to select 6x6 by 1/2. For the material, I'll leave it on mild steel. And then for the placement, I'm going to place on the edge. I can either do by edges or by points. For this one, I'm going to select the center lines on the skeleton. Now I notice that this one and this one are at an angle. If I try to drag that, though, it's going to drag all of these. So I'm going to cancel out of that, or I can just hold the Control key and since I've already moved it, let's put in the 0 degrees to start with. And then I'm going to Control unselect this member and this member so that I'm only putting these two in first. And I'll select apply to that, and then I'll select this one, and I might have to do these two separately. Let's see if we can do them both at the same time. And I will drag that around, and it looks like I am going to have to do these separately. Let's try 45 degrees. So I'll try 40 degrees. That looks like that's vertical, but this one isn't. So I'll Control unselect this one, and so I'll have to put those two in separately. Apply that one, and then I'll do this one, drag that around, and notice that when I got that to the perfect angle, this arrow turns red. These two dots are vertical to each other, these are horizontal to each other. I'll say OK to that one. So I have the vertical beam members in. I'm then going to place the other cross members. So I will select the insert frame again, and this time I'm going to change to 4x4 by 5/16 wall thickness, and I'm going to use a crossing window to select the skeleton sketch at the top. When I do, notice it got this construction line, which I didn't really want, so I'll Control unselect that one. So I have the other four. And if I look at this from a side view, though, we see that these beam members are above the top of the frame, and I want these to be down here on this line. Now, in previous versions of Inventor, we could experiment with selecting dots going around the profile. In Inventor 2020, we can see directly right on the model which dot we need to select. So I'm going to select that dot. That moves these frame members down to the bottom of this line, and I'll say apply to that. and then I will get the rest of them. Now because we have construction lines in here, we can't just do a window selection, or then we have to unselect a whole bunch of frame members. So I'm just going to go through and select all of these additional cross beams. On that one I got the wrong one, so I will control unselect that one. And notice that they are going down the top of the line. I want these to go in the center, so I'll move that to the center. I can check this from the top view. Got all of the ones going down this side, and make sure I have all the ones going down this side. I'll say OK to save those. Once I've created my frame members, I can turn off the skeleton, and it might be easiest to see if you turn on the visual style shaded with edges. Then I need to trim off the members so that they don't intersect each other. Now actually, to do frame analysis, you don't technically have to do this, as it's going to use beam elements, but we will go ahead and trim these. So I'm going to do trim extend, and I will select the frame member to trim. So I'm going to trim this frame member, and I'll select a face to trim it with. I'll select that face and I'll apply, and so it trims off that frame member. I can go around and do this one, and actually you can do multiple frame members at the same time. So if I select these, and notice these, even these frame members that are at an angle, and I will select a face to trim those with, and I'll go through and trim all of the rest of my beam elements. Once you think that you have all of them, you can go to the look at and click on the end of one of the vertical members. Make sure everything that down through the center is trimmed, and so I'll do that on each one of these. Okay, so I have that one. I'll check the next one, and I got the wrong face, so I'll go back and do that again. I have one more to check. Okay, so I have all of my frame members trimmed. Then we're ready to go to frame analysis. Now we can get to frame analysis two ways. We can get it directly from the Frame Generator tab, or we can go to environments and do frame analysis. So I'll just go ahead and click back here where we're at in the Frame Generator. Tell I want to create a simulation. We're going to do static analysis. Our frame members are replaced with beam elements. I wanted to just look at just the beam elements and the nodes connecting those together. So I'm going to go to frame analysis setting, and on the beam model I'm going to select the beam to be transparent. Now I could do that as invisible, transparent. Actually, let's put it on invisible. I think that's where it was, but I must have turn off the shade with the edges. So I've got it on invisible. I'll go back to just shaded. All right, there. So now we see just the beam elements and the nodes connecting together the beams. Every place we have a trim, we have a rigid link connecting together those beams. The elements go down the center line of the frame member itself. I want to change the color of those rigid links, so I'm going to come back to frame analysis settings, and for the rigid links, right now they're gray. I can change those to whatever color I would like to have. So here I have those set to red. Now if there's a tolerance value, let's go back and look at the frame analysis settings again. So there's a tolerance level on the beam model. If this tolerance is set to too small, it won't see the connection, or if it's set to too great, then we might have a connection that goes across here that really shouldn't go across there. So we can experiment with that setting, and after we change it, we click to update lightning bolt to see the changes. I want to change gravity on this particular example so that gravity is going along the z-axis, and so I'm going to go to the loads, and I'll right click on gravity and do edit, and I want to change that to the z direction going negative z. You can flip it to positive or negative. Right, so now I have gravity pointing down, and it's important to set the correct direction of gravity before you put in your constraints. So I'm going to then do a pin constraint, and I'll do a pin constraint at this location, and the orientation of this glyph depends on the orientation of gravity, so that's why I set the gravity first. Now for this pin constraint, we now have 3 rotational degrees of freedom, so this whole crane could rotate around X, Y, or Z axis, but it has to stay pinned to that location. We'll add another pin constraint, and we add the second pin constraint. Now it could only rotate around the X axis. So we removed the rotation around the Z and the Y. It could only rotate around the X axis. I'll add a third pin constraint. With the third pin constraint, it's actually fully defined. The crane boom couldn't move. But of course, we would want this fourth leg for the strength of the crane. So I'm going to do pinned again, and I'll select that leg. Alright, then I'm going to put our load up here on these top beams. And by the way, on these constraints that we just put in here, the pin constraints, we might want to give those a name, and I probably should have used a particular order, like these two and then these two, and let's just see how I put them in. So I did that one up at the top. I did that one, so I do have these in an order that would make logical sense, with these two being ordered together and these two ordered together. Alright, then I'm going to put in the continuous load, and I'm prompted to select a beam. I'm going to select this beam, and I want that to be 500 pounds per inch. Notice that I could change that angle. So I could drag this and change the angle this way, and I could drag the angle this way. And actually, in my experimentation, I accidentally put a instead of a continuous load, it's now less at this end, greater at that end. Let me just cancel out of that and put it in again. So I'll do continuous load. I want this to be 500 pounds per inch. And it changed on me again, so let's just accept that. And we'll come over to the continuous load, and I'm going to say edit. And so it's starting at 50. I want it to be 500 all the way across. And then for the length of that beam is 23 inches, so the actual load that we're putting on here is 500 times the 23-inch length of that beam. Now, so that we don't have that happen again where we have to edit that load, let's go to frame analysis settings again, and let's turn off this heads-up display, and that will make it a little bit easier. So I'm going to, and also while I'm here, I want to make the glyphs for those arrows a little bit smaller. And so here's the load. This is a scale for the glyph. It doesn't change the actual value of the load, just the glyph. Let's do that at 0.5, and I'll apply that, and so that may look a little bit better aesthetically. Alright, I'm going to do a continuous load again, and this time notice that this dialog box comes up where we can put in the load in the dialog box. I'll get the selection tool for the beam, and I'll select this beam, and I'll apply that, and then that dialog box stays up, so I can just select the additional beams and apply it to each one of them. Alright, so now we have our load applied to the frame. We are ready to run our simulation. So I'll click simulate. Alright, we see the displacement, the maximum displacement 0.075, and if I want to exaggerate that, instead of actual, I could say adjusted by 0.5, or even greater if I wanted to really exaggerate that bending. And let's do 0.5. And then if I want to animate to see how that frame is bending, I'll click on the animate and animate the results, so we see it's bending over in this direction. And then if I want to examine the stress, I'll go to the results, and I'll go to normal stresses. I'm going to select S max, double click. Now notice that the numbers range from negative numbers to positive numbers, and the numbers that are positive are areas where the frame is in tension, and then the areas where the numbers are going towards negative, those frame members are in compression in that area. And again, if we want to see how the stress is rising in this, we can go to the animation and play the animation. We can see where the stress is rising and how it's rising. If we would like to turn the visibility of the frame members back on, we could put those to be shaded or transparent so we can see through them and see the beam elements through the frame. We might also want to check with the shaded with edges. That makes it a little bit dark, that makes it hard to see. So put it back on shaded. If we want to know the load at each one of these pin constraints, we can go to the pin constraint and get the reaction force at each one of these legs. Now, two of them will be real close together, and the other two will be real close together. The numbers might not be exactly the same, but they should be within a real close tolerance to each other for the different pin constraints. If I round this off, 48, 48, and I'll check the first one, and 48, 17. We saw in earlier lab why there might be a slight difference between the reaction loads, even though we expect symmetry. Let's finish frame analysis for a minute. I'm going to go back to shaded with edges, and I might want to put some end caps on the end of these four frame members, and perhaps on the other end as well. So I'm just going to do these four ends. So I'm going to do insert cap, and I will select the face. I will do a thickness on this cap, and let's say that that is 0.5 for the thickness, and for the fillet let's do 0.25 for the fillet radius, and we could even do 1 inch. Right, I'm trying to make it match the frame member. I didn't measure that, so I just tried until I got the right size. I'll do the next one. And so the same values, I'll apply that one and create a new one. And I'll do the fourth one. Now you may go back and check the analysis and see if those had any effect on the analysis.